What's up, future physicists? Welcome back to the friction factor. Stephen Derrick here again.
What's poppin'?
We're gonna show you how to do a good old problem 63 in chapter 10.
Yes, sir.
As you see, we got a diagram drawn out already by the lovely Stephen.
Yeah. So in this diagram, we got a block with mass 5 kilograms, and it slides down a surface that is inclined 36.9 degrees to the horizontal. So the coefficient of kinetic friction is 0.25. So that's going to be mu k, in case you're new to this. Not sure what those units are, but we'll just leave it like that. Yeah, that's a mu.
Okay.
That's not a mu. I don't remember what mu looks like now.
All right, so as with all problems, you start with the sum of the forces. So the sum of the forces. You can go.
Okay.
As with all problems, we start with the sum of the forces. So in this case scenario, since it's going downhill, mg sine theta is in the direction of positive acceleration, and tension and kinetic friction is in the direction of negative acceleration. And of course, sum of the forces equals ma. All right, then you start with the sum of the torque, which is in the pulley thingy. Sum of the torque is always equals the force times the radius. In this case, the only force is tension. So TR sine theta equals moment of inertia times alpha. And as we all know, sine of 90 is 1. So you get TR equal to moment of inertia, and alpha equals acceleration over the radius. All right. In this case scenario, since the pulley is a disk, we know that the moment of inertia is equal to 1/2 mr squared. And we also know in the problem it gives us that the moment of inertia is equal to 0.5. So, doing a little bit of algebra, we get that the radius is equal to 1/5. All right. Then you get the tension. Oh yeah, you move some stuff around, going back here, and you you get the tension is equal to moment of inertia times acceleration over r squared.
Yikes.
Yeah. All right. Now you plug that bad boy back into the sum of the forces, so you get mg sine theta minus
Oh, they can't see it.
minus I acceleration over r squared minus the force of friction equals ma. And then you just do like a whole bunch of algebra.
Oh, also, in order to get the force of friction, you need the sum of the forces in the y direction. So when you do that, you get the normal force minus mg cosine theta, which equals 0. Then you get n equals mg cosine theta. And then you'd plug that into the force of friction, which is mu k n.
Sweet.
That's dope.
That's fine, that works.
It's so hard being a YouTuber.
It's honestly considered.
All right.
Thanks, Jesse. All right. So after you do a little algebra, you get acceleration equal to that. All right, you plug that in, and you get 1.14 meters per second squared. You might be saying, wait, I didn't get that. Well, if you didn't, that's because we use G equals 10 because we're, smart physicists. That
We're
do-
efficient because we're lazy and we're physicist.
All right, so that's the answer to A. Well, that is the answer to, yeah. All right, now on to B. B is pretty easy. Since we have A, we just gotta, since B is just asking for tension, we just gotta plug in A into either of those equations. Let's erase it before I spread it.
Oh, I jumped the gun on the R squared.
All right, so we're gonna plug that into this equation there.
With the A we have over here.
And that gets tension equal to 14.3 newtons. All right, sweet. Thanks for coming, guys. Make sure to hit a like. Come back.
Subscribe, support our Patreon at StephenKasuth.com.
And remember, guys, like vector, a quantity represents. Yep, live life like vector.